Well, good morning, good afternoon, good evening to everyone, wherever you may be, somewhere across this lovely world. Thanks for joining us live here today for Serverless Office Hours, streaming on the AWS Twitch channel and on Serverless Land YouTube, and also via LinkedIn Live. Super happy to join you. My name's Julian Wood. I'm a developer advocate for Serverless here at AWS, and I'm joined by my excellent, awesome colleague Dave, who's one of the experts, I think, in my team, certainly to do with events. Dave, how are you doing other than the reinvent lurgy that is still hassling you?
Yeah, reinvent lurgy still lingering
Oh,
for sure, but very good. Thanks. Good to be here. I'm not
good.
sure about being the expert, but I'm just one of the team members. But yeah,
Well,
good to be
excellent.
here.
We also have Jeff and Dominic. Jeff, you're a product manager for EventBridge. Jeff Oriekuya, I was said you pronounce every letter in the name, or just to call you Jeff O. So I may take the easy option. But Jeff, welcome to Serverless Office Hours. How have you landed up at AWS and within the EventBridge team?
I actually just had my 1 year university at AWS. I have really been into events and event-driven architecture for many years. I'm super excited to be here and talk to you about what I think is going to be an extremely cool feature on EventBridge to help you build your event-driven architecture.
Excellent. Well, and yeah, Dominic, thanks for joining us. Also, first time of Serverless Office Hours, so nice to have you with us. You're a little bit closer to us. Or Dave and I are in London, Dominic's in Germany, Jeff's in Vancouver. So we do these things globally. Yeah, Dominic, how long have you been at AWS, and how did you get to where you are?
So I've been with AWS for 1.5 years now, working as a solutions architect for the financial services industry. So I'm supporting insurance companies, capital markets, and banks. And I'm passionate about serverless, and this is why I'm here today. I want to talk to you about EventBridge pipes and the patterns that you can use it with.
Excellent. Well, you're in the right place as someone who's interested in serverless. Also, remember, we are here live, so please send us your questions and comments via whichever platform you're on. Say hi. If we met you at reInvent as well, it'll be super cool to talk about. We already have Zach Jones-Noel, our recently crowned serverless hero, joining us from India. Hello from there. And joining us from Twitch, Awesome1. Hello from Baltimore and Maryland. Well, we're going to be back with Dave, Jeff, and Dominic really quickly, but just zooming back a bit over the past few weeks of what's happening in AWS serverless. Just looking at the What's New post is literally a veritable list of all the things that were announced at reInvent, except for the very top one. AWS is still coming out with new things. So Kinesis now allows you to deliver to Logs.io. So that's a logs delivery platform. And that's come out since reInvent. So obviously the Kinesis team is not resting on any of their laurels from reInvent. And I know plenty of the other AWS teams are doing a bunch of work for the end of the year as well. So don't fret if you're wondering for more features and functionality. We're certainly still working on them. Step functions, large parallel data workflows for data processing. This is super awesome. We're going to have them on Serverless Office Hours for next week. Obviously, EventBridge pipes we're talking about all today. And then also just jumping down to two of the Lambda ones, the second one from the bottom, AWS Inspector support for Lambda functions. So this has got quite a bit of buzz, which is exciting that you can point Amazon Inspector at your Lambda functions and it's going to look for any security vulnerabilities, which is going to be super useful. And obviously the other big Lambda one, which was Snap Start for Java functions. And we had Snap Start last week on Serverless Office Hours. If you want to get any information about basically removing cold starts for Java functions, sounds like something you may be interested in. Certainly have a look at all the information about that, and I will show the link to last week's episode. There are a lot of blog posts that have been going out to support a lot of these features. Some other things as well. More recently, Serverless Espresso extensions. If you're unaware, Serverless Espresso is one of our really good event-driven architecture sample applications, which has been traveling around the world. If you've been at reInvent or a Serverless or a Summit or a Serverless Days or something like that, you've hopefully had a lovely, delicious coffee, and the whole backend server ordering system is powered by AWS Serverless. And the extensions is a new way you can actually build your own extensions, some new functionality you thought of to improve it. Well, event-driven architectures are all extendable. See what I did there? And so you'll be able to add some more functionality. Luca Mezziliera has done a post on a new feature for AWS Application Composer. If you like building things with a visual workflow. This is the one for you. So it sort of connects with your local, if you think of SAM visually, building up your applications with SAM. I'm sure lots of people love text. Lots of people like visual things, myself too, and it makes things a whole lot easier. You just drag and drop things together, connects them together, sorts out your permissions, and sorts out the flow of information. Really useful. A digital learning badge from Josh Khan. That's a new thing that was announced at reInvent. This is a way that you can do a sort of self-paced course, in effect, which you can go through and you can sort of show your knowledge of how some serverless services connect together, and you get a cool little badge at the end, which could be fun. So it's a nice little way to show off that you know some things about serverless. And here, just the top one, which I saw recently, AWS Lambda code updates, visualizing the impact. This is taking a bit sort of through the pipeline of actually getting code into production and using some cool CloudWatch metrics to be able to visualize how that is all happening. I do apologize, I'm jumping around this list like crazy, but they are I'm spotting them as they are of interest. And the second one down, function URLs, really so easy, free URL in front of your Lambda function, but obviously security is going to be a big thing. And so a good post on using Cognito and CloudFront and WAF to be able to secure those function URLs so they're not just open on the internet. But that's the last few weeks on with reInvent and all the big things coming out. But obviously the big one coming out was Amazon EventBridge pipes. Didn't just sort of land on any old day, sort of front and center in Werner's keynote. Jeff, as a product manager, you must think I've peaked here. In 1 year at AWS, I'm done. Now you're going to be knocking on Andy Jassy's door for next year, or Adam Salipsky's door for next year, going, yeah, that's the next one to go for.
Well, I guess like with pipes, it's really hard to beat that, as like we'll see as we go on to the office hours. But I am going to try to raise the bar on this one by delivering a whole bunch of useful features for pipes next year and the years following. So
excellent.
Pipes is great now, but it's going to be even better. Yeah.
I thought you said you were going to raise the bar coming on serverless office hours, that Werner was the top thing you could possibly do at reInvent, and serverless office hours is even raising that bar.
Well, that's what I meant. I mean, if I can get into office hours again in 2023, my year's
sorted. We sorted. Well, excellent, Jeff. I know you had some things you wanted to talk through about EventBridge pipes, and I think you had some slides. Do you want to share your screen and we can get them up?
Yeah, let's do it.
Yeah, and of course, we've got Jeff, Dave, Dominic, and myself all here. So if you do have any questions, comments, and anything, please send them along. Joining us from YouTube, Pawan Pandey, hello, and thank you for joining us. So let me get Jeff's slides up.
All right.
There we go.
Yeah, so I've got some like abstract art to show you here. So as you mentioned, Pipes launched last week at reInvent, and Pipes provides a simple, consistent, and cost-effective way to create point-to-point integrations between event producers and consumers. Let me talk to you a little bit about the problems that we're trying to solve here with Pipes. So if you're a returning member to serverless office hours, you probably figured out that AWS has a lot of different services. These services are designed as building blocks that you can assemble together to build a complete solution. That enables you to innovate faster because you get to focus on the stuff that differentiates your business and transforms customer experiences, instead of things like managing infrastructure, managing data centers, and all that stuff. Yeah. So like, there's some really cool purpose-built services. They're incredibly powerful. They enable you to use the right tool for the right job. If you need like a database that supports massive scale and low latency, well, we got Amazon DynamoDB. Streaming huge amounts of data, Kinesis has you covered. You need a queue that scales, handles spiky workloads. Like SQS offers almost unlimited throughput. The idea is when you assemble these building blocks together, you get a solution that's highly scalable, resilient, and reliable. And you have the flexibility to drop in new building blocks as your needs evolve. So connecting these blocks together, it looks super easy. It's just that gray line there between the boxes. So you want to consume DynamoDB stream events from SQS queue so you can process changes to your database as they happen. Like, no problem, right? Well, what you don't see and what might not be so obvious is to get the DynamoDB events onto an SQS queue, you got to write code. that pulls a DynamoDB stream and publishes events from that stream to the queue. So we call this code integration code or glue code, because it's gluing these services together. So, all right, glue code doesn't seem so bad, like, until you got to writing it. Like, first off, like, these services at AWS, they often use different technologies to communicate. And you're required to know the nuances of each technology. So for example, Kinesis, use the Kinesis client library. You need to figure out how to pull a stream. You got to understand shards. You got to make sure you keep track of the sequence IDs to maintain ordering. You want to connect that to SQS? Well, the Kinesis client library is going to help you very much. You'll need to research a different library or two or three. You need to understand how to implement multiple consumer workers against your queue to maximize the throughput. You got to know how to mark and delete your records correctly. So cool, now you understand the sources and the targets, but you got to handle errors, got to figure out batching, combinations of batching and errors, and yeah, talking about implementing partial batch failure mechanisms. You got permissions, authentication, rate control, the list goes on. So cool. So I'm finally done writing my code, and we're still not done. You got a performance test to find the right CPU and memory allocation. You got to make sure your integration can handle the required throughput through more load testing, deploy the code, ensure you have the right monitoring set up, and yeah, get paged at 2 a.m. when something goes wrong with your code. Julian, if there only was a way to focus on the stuff that differentiates your business and transforms your customer experience instead of writing all this undifferentiated glue code. Well, there's a way now. So Amazon EventBridge pipes. They provide a simple, consistent, and cost-effective way to create point-to-point integrations between your event producers and consumers. So today, Pipes supports consuming from 6 sources. You'll see 5 of them on my diagram there. Self-managed Kafka is the 6th one. You get enrichment through 4 services and delivery to 14 different AWS services, including HTTP endpoints via API destinations. But right in the center of my picture here, you see filtering. So with Pipes, you choose which events get passed on to the target, and you're only charged for the events that match your filter. If you've used EventBridge event buses in the past, you'll be happy to see that the filter patterns use the same syntax. Right next to the filtering, you see this enrich and transform step. So you can transform the event using conditional business logic, or you can enrich a thin event using these services. Like, for example, your source might contain a simple customer identifier, but your consumers need more robust information about the customer. So with enrichment, you can do things like reach out to your Salesforce instance, for example, pass that identifier to the Salesforce instance, get the detailed customer information back from the event, and then send in that rich event, that thick event, onto the target using the exact schema that the target expects. A bonus to this is that the enrichment is done synchronously, so all the event ordering is maintained, even going through that event enrichment step. Now, it's these 2 steps, actually, this filtering and enrichment. They're both optional, but I consider this the secret sauce of Pipes. These allow you to implement some really, really cool architectural patterns that are really hard to do elsewhere. And Dominic actually is going to explain a little bit more about some of these patterns that Pipes unlocks.
Thanks, Jeff. Just before we get to Dominic, just from a sort of level set as well, what's the relationship with EventBridge Pipes to normal EventBridge?
Yeah, so EventBridge Pipes and EventBridge, we're transforming it from just event buses into a product suite that helps you build event-driven architecture. So now under EventBridge, we have the event buses, we have EventBridge Pipes, and we also have EventBridge Scheduler. And so that's the relationship. You don't need to use event buses to use Pipes. You don't need to use event buses to use Scheduler. You don't need Scheduler with Pipes. It's 3 services all under the same banner that help you write event-driven architectures easily.
Excellent, thank you. And I suppose schema registry as well. That's another feather in the cap. Yeah.
I'm also the product manager for schema registry, and my team is going to hate me for not mentioning that. But yeah, that's there too. I'm discovering registry and a whole bunch of new features they're going to be introducing in 2023.
Oh, exciting. Yeah, Dominic, let me bring up your screen as well. Oh, it's not available, but yet, yeah. Oh, there we go.
There you go. All right. So thank you, Jeff, for the introduction of EventBridge pipes. And now we want to take a look at how you can implement architectural patterns with Amazon EventBridge pipes. And if we think about this title, implementing architectural patterns with Amazon EventBridge pipes, I think now we have the pipes part covered. Based on the introduction, I am confident that you now know how pipes work and what the benefits are. But I think what we should clarify next is what do we mean by patterns and why would we use them? So in software development, we refer to patterns in multiple contexts, and we don't always mean the same thing. Today, when we talk about patterns, we will refer to enterprise integration patterns, architectural patterns that help us integrate different components. And as you probably guessed, this is exactly what pipes does, and this is why it's really exciting to take a look at those patterns and how we can implement them using pipes. But before we get to that, why would we use the patterns? Well, you already heard that there are a couple of things that we need to consider when integrating different components. There are nuances in technologies, there's the error handling, there's the ordering, and there are so many more aspects. But then working as software engineers, we're not only expected to provide viable solutions to a given problem, but we're also expected to do so efficiently. And finally, we're also asked to estimate how much time will your implementation need. And that oftentimes is a big problem. But using patterns helps us also with that because the patterns have been used before and they have been tested before, we know they work. And because they give us a clear blueprint, we also know how much work it is. And as added bonus, because some of the patterns are also widely known across teams, it helps us with the communication not only within our team, but also across teams. Now, these are just 3 reasons why you would want to use patterns. I'm sure we could extend that list quite by far if we wanted to, but instead, let's get started and see how we can use those patterns to make our lives easier. I'm sure that at some point, you probably have heard that when you build software, you should make sure that your components are loosely coupled. And how would you typically achieve that? Well, one approach that we often see is that you place a queue between 2 components, and this way the first system, which is also called the upstream system, can output the data at its own pace, and that without overwhelming the downstream system, which can then in turn also process the data by pulling data from the queue and process it at its own pace. So if we take a closer look on the pattern idea, well, we have different components in our architecture. They have individual concurrency limits, so we shouldn't really connect them directly, but with queues. And connecting the components with queues helps us to avoid that overloading because then each of the services can process the messages at its pace. What are example use cases for this? Quite frankly, we see this in a lot of applications, and I would hope that we see it even more because this is such a great pattern to help us reduce the load on downstream systems. The prime examples for that would, for example, be a flash sale or a lottery entry where a lot of people try to sign up in a really short time frame. And because all those people try to write, there's also not a lot that caching can help us with that. So we really need to make sure that we get all the messages and can process them. So what does the implementation look like? Using pipes, you can create a pipe that connects an SQS queue with an AWS step functions workflow, and it does so directly without you having to write any code. So why is that a good thing? Well, think about how you would have achieved the same thing before. So before that, you may have written a Lambda function, and that would have had custom code in it. In many cases, it wouldn't really do more than pulling the queue and calling the step functions workflow with the results. Or maybe you would have even written your own retrieval and processing logic using the AWS SDK, and you would have hosted that in an ECS container. And then, of course, the question is, how do you host that and who takes care of that? So in both cases, you need to write code. That code will live forever. It's going to be maintained. You even potentially have to take care of the additional resources. And so that just adds some extra work for you. Now, of course, when we look at this pattern, even though the example here is with SQS and step functions, it's of course not limited to step functions as a target. You have heard before, there are many targets to choose from, and you can use the same pattern with the other targets as well. And then, as always with pipes, you can enable filtering and batching, which will also even help you to reduce your costs. Using pipes, you also get automatic retries. So in case of a retryable error, pipes will automatically retry that for you. And you can optionally enable dead letter queues. So a queue which stores all the messages that were not successfully processed. However, there is one thing to keep in mind, and that is that the pipe throughput is not configurable. So what you really should do before putting that into production is you should load test your application to see how the pipe and how the downstream resources behave under that load. But of course, load testing is something that you want to do for every system that you build and that you want to put into production. Now, if I were you at this point into the presentation, I would say, enough slides, show me a demo, and don't worry, we have you covered. Bear with me for some more time and some more patterns, but Dave will walk us through a demo after that, and you'll get a closer look at what it looks like when you're actually using pipes. So next up, claim check pattern. It's also a very popular pattern that is found in many event-driven applications. Let's take a look at how that works. In an event-driven architecture, we need to limit the size of event messages. We achieve that by splitting each event into a reference, which we call the claim check, and then the related payload. Then we can store the payload in an external storage, and we only need to pass around the reference in our system. Why again do we do that? Well, here's an example. Imagine you build an e-commerce platform. Every order, of course, is associated with a specific user, and that user can be identified by a user ID. Therefore, there is no need to send all the attributes for that particular user in every event. But of course, at some point, we need to know the address of that user, for example, to determine the shipping costs or be able to send that package. Now, of course, you could do all of that in a Lambda function, but then the Lambda function consists of two things. There is the enrichment business logic, and then there is the glue code between the services. And with pipes, we can do that enrichment for every target inside the pipe. And we can therefore hide that complexity from the rest of the system. And we can even do so without writing any glue code. So even if you want to use API destinations or API gateway or step functions workflow, that is also possible. And again, this pattern is really flexible. It works with various sources, various targets, and with the different enrichment options. And again, you can use filtering and batching. So if there's anything that you don't need to process, or if you want to process batches, that is possible. And again, it will reduce your costs. Again, here is one thing that you should consider, and that's the target's message size limit. So depending on the target that you choose, the targets still have their message size limits. And let's say you want to enrich with a higher resolution profile picture of your message, and you want to send that to step functions, that may not be the greatest of all ideas. So next up, the content filter pattern. So in the last pattern, we added more context to a message. Working in the financial services industry in Germany, my customers actually oftentimes ask me the opposite. How can I remove data that I'm maybe not even allowed to process in downstream services? So removing personal identifiable information is one possible use case for the content filter pattern. But of course, simply reducing the storage cost if you intend to retain the data for longer periods would be another. So what exactly are we trying to do? Well, we want to process data. Some components only need to process a subset of that original data. And as just described, it could be that the downstream system is even forbidden to have access to the complete upstream data for regulatory reasons. So the content filter pattern allows us to filter unwanted messages or unwanted attributes on pieces of the message, and we can do so easily within the pipe. So in the architecture diagram, we can see what one of my customers wanted to do. they ingested their data into an Amazon Kinesis stream. And because that data contained personal identifiable information, they weren't allowed to store that for a long time. So they needed to limit the retention period of that first Kinesis stream to a short time frame. However, they actually wanted to use that data for data analytics, and it should be around for quite some time. And the data that they needed for analytics is not personal identifiable information. So now what you can do is you connect those two streams with a pipe, you filter out all the attributes that make up the PII data, the personal identifiable information, and then you can retain that second stream for longer. Again, as you can imagine, I demonstrate this pattern with a Kinesis stream, but it does apply to other sources and targets as well. And in addition to the considerations we already had with other patterns, using pipes as a filter may even be more cost-effective than using AWS Lambda, because if you just want to remove certain fields, you can do so directly in the pipe, and we use the so-called target transformers for that. And you may not even need the enrichment then. And again, you have encapsulated that functionality within the pipe. So the source and the target don't need to worry about any changes to the message that you do, but you can really do that where you should be doing it, which is at the connection of the two services. Another quite common pattern is the message translator pattern. And here we have an event-driven architectures where we have event senders and receivers that are independent from each other. And for that reason, we also want to give independence to the teams, which means that they can decide on what the event structure should look like. And they may come up with event structures for similar events that have a different format. So if we want to allow those different components to communicate with each other, we need a translation for those events before we pass them on to a different component. And one simple example would be that we have an event that contains coordinates, but our downstream system wants to work with an address. I'm sure you know the drill by now. Of course, we use a pipe and we can use enrichment. As for the actual logic, there are ready-to-use geocoding services available. So a geocoding service is a service where you pass the coordinates, and then you get the address of that location. So there is no need to develop anything for yourself, and therefore we can just integrate the existing endpoint for geocoding using an API destination and forward the event to that before we forward it to our target. Nice. So of course, this assumes that there is some actual computational effort for translating the message. Like here, we have the coordinates, we want to have the address. There's actually something that we need to do. It could also be that we have a purely syntactical difference in the messages. So for example, the naming of the fields, or we have a different structure. So the content is all there, but we need to reorganize our event structure. And in that case, we wouldn't even need enrichment. We can also do that with the transformers. And then again, pattern is suitable for various targets. The pipe encapsulates the whole enrichment. So again, we can hide this complexity from the rest of the system. We can filter out messages that we don't want to forward. And again, that saves costs. So what if it's a little more difficult to transform our events into the structure that our targets need to process? So maybe we have multiple senders and each of them have their own structure. Normalizer to the rescue. So the idea behind the normalizer is similar to what we have seen in the message translator, only that this time we have various sources and all of them have different formats for events. And then the normalizer pattern routes each of the events through a specific message translator. One easy example could be how the names are stored in our system. It could be all in one field. It could be split by first name and last name. Maybe it's first name, last name, and an array of middle names. There could be even a nested structure or whatever the developers of the source system thought was appropriate. So in that scenario, it feels very natural for us to use a step functions workflow to divide by event type. And then we have individual components which do the unifying process based on the type of that specific event. In the diagram that I depicted above, you can see that I'm using AWS Lambda to do so. But in our name example, chances are we could even do that using the transformers only. And then once we have unified our events, we can put them again into our downstream system. So in this case, the EventBridge bus, and then downstream systems can pick up the event from there. We have a unified name structure, and we can work with that. So because the pipes enrichment step can include lambda or step functions, it is quite powerful. And we can even do something like scatter gather pattern inside the pipe. And what is that pattern about? If we have different components which could process a specific event, so let's say we're building a marketplace and every item is provided by multiple vendors. So when an order comes in, we want to make sure that we use the best provider for that particular item. It's unclear which provider is the best in a specific scenario. So in a given situation, we query all of them, and then based on the result, we want to make our pick. So in this scenario, as you can see it in the diagram, we have an incoming request to the pipe. Inside the pipe, we can select the best offer, and then the event that results from the pipe will actually have that best offer in it. So while this is quite powerful, it also means that in this case, we're hiding business logic inside a pipe. And technically, we can do that, but we also need to make a conscious decision whether this is really what we want. And for this reason, this is also the last pattern that I wanted to show you today. And certainly, we could extend this list by quite a few more if we wanted to. And I am, in fact, happy to hear how you are using pipes in the future, and also possibly add your patterns to the list and also the use cases that you're using pipes for. But the key takeaway of this presentation is exactly this. You shouldn't just rely on the patterns that I have shown today, but it really should be a starting point for you to get creative into simplifying your architectures using EventBridge pipes. And I'm happy if the ideas that I showed you today gave you a good starting point for that. And I think with this, it's now your time to go build with it.
Oh, thank you, Dominic. I love the idea of the patterns as well. And what is sometimes surprising to people when we're thinking about event-driven architectures of the sort of slight concern of, oh, this is all new. But literally every single one of your patterns are 20 years old. In fact, enterprise integration patterns, Gregor Hopper, he actually now works at AWS, coincidentally, but that's, that doesn't mean it's an AWS thing, but these are sort of industry standard patterns, scatter gather, these kind of names have been there for 20 years. And I think architects 20 years and application designers 20 years ago loved the idea of them, but they were super hard to actually put together because you had to write a lot of code to implement all of this. And serverless just makes this even better, even with things like step functions and EventBridge and Lambda before then. And so, yeah, this EventBridge pipes I love that sort of thing of taking 20-year-old ideas and just making it so much simpler to use and use it as a sort of modern event-driven architecture, which isn't actually so modern, but is much easier to do. So love it.
Well, even the name pipes is like 50 years old, right?
That's it.
Yeah.
Well, in fact, Jeff, for people who may not know, where does the names pipes come from and what's its history?
Yeah, well, I mean, pipes, I think some people probably figured it out. We are basing this on Unix pipes. It's a composable way to move, for us to move events from service to service. We named it intentionally in homage to that.
Yeah, perfect. I mean, that whole idea, I've done a whole lot of work with PowerShell as well recently, and that's also got the same thing. And Jeffrey Snover, the inventor of PowerShell, took the same Unix philosophy of pipes and being able to pass these things down the pipeline. Yeah, super powerful. Node.js has a pipeline as well, so yeah, very, very powerful. Yeah, Surab, thanks for the pipe.
I saw that comment. I'm like, exactly. Yeah.
Exactly. Excellent. So I'm just going to jump. We did have some questions. I know this wasn't quite related to pipes, but Surab, again, we may just cover it. Will EventBridge event buses ever get to SQS-like monitoring and observability out the box? Surab, is there anything specific you want? Because there is a bunch of monitoring and observability for EventBridge. What does SQS have that you feel EventBridge is maybe missing? And certainly we'd be happy to feed that back. Anything, Jeff or Dominic, to add?
I don't know how much I'm allowed to talk about the roadmap, but stay tuned, I guess.
Stay
is what I
tuned,
would
stuff is
say
coming,
on that
of
question.
course.
Yeah.
Of course. And of course, because I'm originally from South Africa, Joshua Corza, hi from South Africa, hi to you too. There was just a three-part question. Surab has been busy. Does enrichment invocation count towards account quotas? How does scaling and reserved concurrency work in that scenario? And how is it different from using glue code? So I think the glue code we maybe covered in the intro, but yeah, how would we think about the integration with other services and quotas, concurrency, scaling, and all of these kind of things?
Sure, I can take a stab at it. So for the first one, the enrichment, it does count toward your account quotas. So for example, if you're enriching using Lambda or API destinations, you'll be charged during the enrichment phase for what those services are using. Those won't show up as pipes charges. Those will show up as charges for that particular service that you're using. Same goes with the source and the target. Pipes is just the connective tissue between them.
Okay, so that makes it actually simpler, I think, to understand that pipes isn't a big black box with its own charges and everything. If you're using enrichment via API gateway, step functions, or Lambda, your Lambda functions, your API gateway, your step function is going to have a name, and you're going to be able to allocate those directly to those enrichment processes.
Correct. And pipes does have charges, unfortunately, I guess, but we tried to keep them really, really low. So the pipe itself, you'll get charged in the big regions about 40 cents per million messages. That comes after filtering, and that's the only charge that you'll get levied with pipes. The second question on the scaling, and I think scaling concurrency was asked about a particular use case. I think I need a little bit more information about the use case that you want me to address. I can let you know that pipes is very, very scalable and does support very high concurrency. There are some soft limits that we've implemented that you can see on the EventBridge quotas page. But all those limits, if you're a customer and need those increased, talk to us. We can, all of these are not lines in the sand that can be increased.
But I suppose with that previous comment you made about step functions, the enrichment process and those other kind of things, sort of handing off to a separate service, in a way, Lambda would be the same. If we are talking about reserved concurrency, your reserved concurrency quotas will be applied. So if you are, EventBridge pipes can handle amazingly high concurrency, you may then need to increase your concurrency for your Lambda functions to be able to support that as well.
To handle the feature that is pipes. And I think the last one was the difference between glue code. I think Dominic had a good slide there talking about, I took some notes, loosely coupled components. And so this allows basically with glue code, you need to consider the source and the target and make sure that you're pulling the source and delivering eventually to the target. If you're using an enrichment, you don't need to worry about that. We'll just invoke the enrichment. You send the response. You don't need to make it specific for a certain source and a certain target. Also things like back off and retry, logging and metrics, DLQ. Those are things that you don't need to worry about anymore. That's our responsibility with pipes. We'll look after all that for you. You just need to write that code in the enrichment that handles that event coming in and sends that event back out. So I would say that's a major difference between writing your own glue code and using an enrichment.
Okay, excellent. We're going to get on to Dave's demo, and then we do have some other questions. We will not let them lie, except for the last comment. Obviously, we didn't spot this. There's a pipe in Dave's name. I mean, really, he's built for pipes. Dave is built for pipes.
Pipes everywhere.
Pipes everywhere.
Once you see them, you'll never stop seeing them.
It's everywhere. So yeah, Dave, you've got some stuff to show us.
Cool, yeah, just going off Dominic's examples, really. So it's been just diving into, excuse the cold, by the way. Yeah, just been diving into pipes this week, really, and create some examples. So if you head over to serverless.com/patterns, and then down on the side here, you can actually search for pipes. Someone asked about CDK support. CDK support is coming. So bear with us on that, hopefully very soon. But for today, we'll be using CloudFormation to show some examples. And I've been so go for it.
So that means, is CloudFormation coverage still coming? Oh, we're about to show it, so that's
it's here.
yeah. So Dynamo. So I'm going to show two. Hopefully, got time for that. And I literally just created a new AWS account and deployed this stuff in that AWS account. So if things don't go our way, trust me, they work. But I'm pretty sure they will. So we got DynamoDB streams, excuse me, into an EventBridge bus. Now, this is a pattern I find personally quite interesting because it allows us to listen to data capture change events from Dynamo using streams directly into EventBridge without having to manage any code in the middle. Now, why would you do this? And I've done this in the past before I joined AWS. As an AWS customer, I would raise events when things were changing in the database, right? I would write to the database and I would raise an event for downstream consumers to be able to process this stuff. Now, there is kind of a bit of a debate here, I guess. Some people say these aren't domain events. I guess they're not. Be very explicit in your events. But these events are and can be very interesting. So if you created an order, or updated an order, or inventory item, or deleted an order, or anything like this, all these changes can be captured and put into EventBridge, and then you can farm them off to 20 plus different targets and have this event-driven solution that doesn't really require much code. In fact, it just requires a pipe, and the pipe can manage this integration for us. So what we're going to do is just dive in. Excuse me. So you have to bear with that. What we'll have to do is dive into the code. Now, all the code you'll see here is open source. All the code here is online on serverlessland.com. So if you want to run this yourself, you can do that. I've pre-deployed this into the account to save us time today. But you can check it out.
I'm putting the link into the comments, so you've got the link to the serverless land patterns with the EventBridge pipes.
Cool. And as Julian talks, that gives me perfect time to drink to get rid of the cough. Let's keep talking, Julian. Have yourself. That'd be great.
I didn't want to say the obvious thing, like you should really stop smoking that pipe. I know we can blame it on reInvent as well.
Just keep going. Yeah, definitely reInvent. So first thing we do here, so we're going to create a DynamoDB stream to EventBridge. So we create a table, right? And it's just a basic table here. We could have used a simple table actually from Sam, but decide not to. So we've got a table, we've got an attribute ID, and just some basic setup here. We set up a stream here, and we're actually listening to new and old images. So new images that come in, and changes made to the old ones. What does that mean? Means that when we get the event, we get to see the delta, we get to see the new object and the old object. And it's very good to working out deltas downstream, like if the amount changed on the order, what was the previous amount and what is the new amount? And with DynamoDB streams, for those who do not know, you can check out this link in this code here. You can listen to keys only, new images, old images, and various different things. Next thing we do, is create the event bus. Very simple event bus. We're going to create a dead letter queue for a pipe. Again, just a simple thing here. So let's get into the pipe stuff. First of all, we have to create the pipe role, right? And this allows the pipe to do what it needs to do in summary there. So we have a policy for the target, and we have a policy for the source. The pipe, the left and right parts of it. So here we create a policy for the source, and the source is Dynamo, right? So it's DynamoDB stream. So we give pipes the ability to do what it needs to do to process this thing under the hood, right? And remember, if you're not using pipes, you can do this yourself. That's fine, but these are the kind of things you would have to do. So what it needs access to is like describe stream, get records, child iterator, and list streams. Now you might be thinking, how do I know which ones do I need when I'm creating my pipes? And what I recommend you do today, at least, is go into the console and actually create a pipe, example pipe between two resources, and then look at the generated policy at the end of it, and that'll give you an example. I fed some feedback to the team to see if we can get some more documentation on that. So yeah, if you're interested in that or different connectors.
And
feel free
Sonos did
to
also say, can you use a SAM connector to create policies for a pipe role? I don't believe so at the moment, but I'm pretty sure that would be a very cool thing for both teams to work on, because that seems like that would be super cool.
Definitely, yeah. I've had about 3 people ask for that already this week. So yeah, it's super cool.
4.
4 now. Yeah. This one for Jeff. Come on, Jeff, let's do it.
I hear you. Yeah, I hear you. There's so much we want to do with pipes.
Yeah, I know. Yeah, it's just literally just to start. Target and policy. So what we're going to allow pipes to do is just put the event onto the event bus. Down here, what we do is we define the pipe. So what we do is give it a name, give it a description. That's cool. We pass the role, and then we pass the source, which is the stream, and then we pass the target. Now, things to consider when you're writing your pipes is the parameters for your source and parameters for your target change depending on the target and source type. So because we've got DynamoDB streams here, there are some parameters that we need to set, and some are optional. This is all documented online. So we set the starting position to be latest and the batch size to be 1 in this example here. We set an optional dead letter queue there. On the target on the other side is the EventBridge, the event, right? And what do you want to raise? Now, I've said I want to raise a user details changed event, and the source is going to be myapp.users. Now, you can change this to anything. You could delete this and have AWS default for you, but I recommend specifying them and being explicit in the event name here. And that's it. You know, in 86 lines of code, we have a pipe set up. Now, I have deployed this in my account, and you can see it's this one here, DynamoDB to the EventBridge pipe. Well, if we click on that, we can actually see the stream to EventBridge. And if we click on, we can click on this directly, we click on the target directly to get to the resources themselves. This is the role that we created, sorry. Excuse me. Yeah, who thought it'd be a good idea to stream with a cough? So we got the DynamoDB EventBridge users. So I'm going to explore the table, and you see we have nothing in there. So let's create an item. And let's just say hello for now. Now, in theory, what should happen is a stream should be created. A stream is created. This event will go to our EventBridge bus. Now, what I've done off camera is I actually set up a rule on our EventBridge bus to log all the events into a CloudWatch log group so we can debug and see what's going on. So with some luck, if the universe is with me today on this new AWS account, just for this stream, never tested before, can we see some stuff in CloudWatch?
Testing in production. I love it.
Yeah,
Dave.
the power of live demos. Yeah.
Is the universe with me today?
The demo gods he must have been very kind to.
I know. Wow. Okay, so here's my log group that I created. Yes, look at this. And we have an event, right? So we just added something in there, and this event has come in here. So as you can see, we've got the detail type.
Can you just zoom in, Dave?
Sorry.
Not that we don't believe you, but
yeah, this is all manipulated DOM, so none of this is actually real. It's just static website.
Hey, localhost, I see the URL.
That'd be good, wouldn't it? Don't make me laugh. So we've got the detail type, user detail change, then we got the source, and then in the detail itself, we've got the object from DynamoDB, right? And you can see that there. So then downstream processes can kind of parse this and use this. Now, one thing you might want to look at doing is using the input transformers to actually transform the object before it goes inside the detail object. Why would you want to do that? Because you might want to does your consumers really care about some of this DynamoDB data? Probably not. So just pick out bits that you want downstream. So this is just a quick example of DynamoDB streams into EventBridge. Again, think about the use cases. Think about what you're doing as you're using EventBridge and using DynamoDB. Can you have this event-driven system that when you're making changes, could be anything, configurable changes in Dynamo, could be internal things, could be external things for customers. Could you then trigger EventBridge events and have downstream consumers process these, and again, internally or externally, And what I like about pipes, to be honest, the biggest thing I like about pipes, it literally opened up. I think it's over 100 different like integration patterns, right? Point-to-point integration patterns, and that's very interesting space to explore, because it just opens the door to new kind of things we can do for our customers, and just patterns in general that we can explore as engineers. So I'm super excited about that. Now, there's one more I'm going to quickly rattle through. I'm cautious of time, that you might be interested in, which I was interested in, which I've done today or yesterday. I can't remember. It all merges into one. But it's this idea of this enrichment pattern. So you can actually take an SQS messages, raw messages, simple, thin messages into pipes and actually enrich them, and then downstream for Lambda. How this one works exactly, this is the example on there. It'll pull the SQS for you, which pipes handles all that for you. And then as the message comes in, we actually transform the message into JSON, because it's going to be text from SQS. We get the order from DynamoDB. Here in the enrichment phase, then we verify the item. We say if it's found or if it's not. Now, there are a few caveats to consider, and I kind of tweeted this today if you follow on Twitter, but from enrichment, just make sure you return an array for the downstream consumers. So when you get an item from Dynamo, in this example, get item, you're going to get one object. So you need to transform that back into an array, which you can see in the example code. If you don't want to trigger the downstream consumer, the target here, you just need to pass an empty string, an empty object, or an empty array, and then pipes won't do that. So these are just things to consider if you're enriching.
So that's a cool hack. So if the enrichment process returns nothing, pipes just knows, well, this is not quite you've done an enrichment step that sort of acts as a way as a filter as well, and you can use the cool branching logic in step functions to then, you don't have to have another process to then go and discard that message.
Exactly, yeah. And I think this is the interesting thing with enrichment. Enrichment gives it the name of kind of, okay, we're here to enrich the data. But you can also do some other interesting things, like Dominic said, about like taking PII information out, right? Or changing the message payload. Or what happens if you had 10 items from DynamoDB, but we only wanted to return 2 for some reason? Some business logic in here. So we can basically inject some logic here before it reaches downstream consumers. But as Dominic mentioned there, you just got to be careful about how much you want to put in there and how you want to manage this kind of going forward. But again, just opens up the door for some patterns.
Just a quick thing I thought of, with SQS going to pipes, obviously things are coming in batches. You've got a batch size of 1, but if you have a batch size of up to a ridiculous amount, does the enrichment step then receive the whole batch or per item?
That's a good question. I think it's per item. Do you know, Jeff?
It'll get the whole batch.
Okay.
Yeah, that makes sense. So
right, yeah. So So on this example here, we'd have to obviously map over and handle that differently, right?
Yeah, that you could do that. Yeah, I know, Jeff, you mentioned to talk about this. Kushnava, thanks for joining us from YouTube. Yeah, SQS to step functions, not quite what we're showing here, but similar to process synchronously. Is this feature not available as of now?
It is available as of now. So you can create a pipe to invoke a step function synchronously or asynchronously, depending on if you're using standard or express. You could make a pipe to do this in minutes. It's ready to go. Okay,
excellent.
Yeah. But yeah, cautious of time. But if anyone wants to look at any patterns, serverless patterns in general, literally head over to serverlessland.com. We have 410 patterns now, which is incredible. But if you scroll down here on the left, we've got this EventBridge pipes one. And if anyone watching wants to contribute to patterns or has any ideas or questions, or wants a pattern created for them, just reach out. We have people here that want to get kind of hands-on with the stuff. Feel free to create some, and just keep an eye on this, because this will be growing over time.
Yeah, Dave's already put a whole bunch of stuff in, but yeah, certainly some more going. Just wonder one thing under the hood. I know under the hood that Pipes is using the Lambda event source mapping.
So we don't specifically use a Lambda event source mapping. We're using the same polling infrastructure as Lambda event source mapping uses. Unfortunately, doing the answer to this one really is I guess it depends. There's going to be some workflows, especially if you're, I would say, if you are invoking Lambda as your target, where event source mapping may make more sense than using pipes. I talked with a customer earlier this morning, though, that had a difference of opinion. For them, it was more cost effective to use a pipe for their particular workflow.
Okay.
I would say the big differentiator is that if you want to pass this on to some other service that's not Lambda, pipes is your go-to choice. But again, it depends. Test on yourself, do some price testing, do some load testing, and see which works the best for you. Both choices are
so the bigger picture thing is pipes has obviously got a lot more targets that it can send to. It's also got that enrichment step. I know that may sound a bit weird if you're sending it to Lambda. Well, you could do the enrichment in Lambda. But yeah, no, that's good information to think about that. Time is running out, so I just quickly want to grab some questions. Thanks, Graham, for joining us. Does this treat throttling rate limiting in a smart way, or do things just go too fast and retry out of order? Say if we have a Lambda transformer or a step functions transformer. I mean, it's going to maintain the order as far as I understand. You're going to get your throttling on your Lambda, but then is pipes just going to wait until it stops getting the 449s from Lambda and carry on?
Yeah, on this one, I guess it depends as well. We have batch sizes and partial batch failures in there as well. We try to do the back off and retry intelligently and in a smart way, but once you start backing off and retrying, I don't think I would be able to guarantee that you have things in ordering anymore.
Yeah, and ordering is a complicated thing. I mean, especially specifically with things with SQS non-FIFO queues. If things aren't processed, they're going to just land up back on the SQS queue within your visibility timeout, and then another service is going to pick that up. Ordering is tough in that kind of scenario. Graham did have one other question. Let's see if we can do this. Does the SQS integration use send message batch into SQS? Say if we did DynamoDB streams to SQS using pipes, I want to do a fair comparison against a Lambda implementation that uses send message batch. Yeah, Graham, I think you've answered sort of your own question. I want to do a fair comparison. I think it would be worth looking at that. I mean, obviously you can you can do the configuration within the pipes, so yeah, going to be different. Yeah, give it a try. Grant's got a quick one about first time step functions SDK integration in our pipes. Your claim of not hating the Lambda team is looking a little shaky. We love the Lambda team. Jeff has just said they're using some of the polars underneath from Lambda. So Lambda's got some cool stuff that other services can use. And Lambda's all available there for a lot of the transformation steps. So yeah, certainly loving the Lambda team, I would say.
We could not have pipes without the Lambda team. It wouldn't exist. So not only do we love them, but they're essential to the success of pipes.
Cool, excellent. I won't stick that on. Jeff, Dave, Dominic, that flew by. We could do another whole hour. There are 1,000 different patterns I'm sure people want to look at and demos and all that kind of thing. I really appreciate you taking the time to show us pipes. I think it is phenomenally exciting, not just from the EventBridge thing. From the EventBridge event buses, this is a whole brand new world of event-driven architectures, which is front and center in Werner's keynote. So thank you so much for joining us.
invite us again, Julian.
We certainly will do.
Awesome.
It's always open. And just quickly, I will put that up. We do need to go though. But next week, another reInvent release, step functions, large scale data processing. So we're going to have some cool people talking all about that. But thank you very much. Same time, same place next week. Thanks for joining us for Serverless Office Hours. And so great to have Jeff, Dominic,